Hi viewers, this is Dr. Jana and you are watching video with me on data structure part 2. In the last part of our video, we discussed the fundamental of these data structures and we last discussed about the heaps. And as you know, heap is a special tree-based data structure in which the tree is a complete binary tree. Try to understand. So generally, there are two type of heaps. One is the max heap and another is the min heap. In max heap, in this type of heap, the value of the root node must be the greatest, that the key value I am talking about, among all the child nodes, and the same thing is also for all the left side and the right side subtree. That means parents should have the larger value, the children should have the smaller value. Then coming to the main heap, it is just the reverse. The value of the root node must be the smallest among all the child nodes, and the same thing is also applicable for the left and the right subtree. It's clear that you can see here this being a minimum heap, the root is the smallest. You get it now? Root is the smallest, and the left subtree also it is the small here, and also here you can see the larger values are there in the left node and the right subtree, right? Then another type of data type, that is the hash, and we will be using some hash tables. This hashing, it refers to a process of generating a fixed size output from an input of variable size. Try to understand. The input will be variable size, but the output will be a fixed size. So this is the case, and we are using a mathematical formula that is known as the hash function. And these techniques determines the index or location for the storage of an item in a data structure. Now we are using hash table. These types can be implemented as a linear or non-linear data structure, and the data structure consists of a key value pair. For example, you see we have the same thing, 0 indexed, 0, 1, 2, 3, 4, 5, like that, all indexed and there. So suppose I want to put the value 10, 11, 12. So I go for number module 10. So 10 module 10, the remainder is 0, so it will be here. 11 module 10, it will be 1. So 12, like that. If you go for that one, now 12 divided by 10, remaining is 2, it will be mapped here. 13, like that. Suppose you go for 20, 21, 22. Similarly, you can see this will be there in this group only. It's clear? So then we go for the most important data structure. It is similar to a tree as we see in the nature, but it is upside down. That means in the naturally we see a tree, that root is at down, but here in our data structure, tree is at the top and the leaves at the down. You can see the tree is here, the tree root is here, and the leaves are here, and the starting that whatever the things you see it here. So this we called as the root. This node we called as the root, and inside the node, inside the circular node, some value is written. It is ABCD written. Sometimes it can be written some number also. This we called as the key. Okay, this is the left subtree and this is the right subtree. Similarly, this is the parent, B is the parent, D and E the children for that one, C is the parent of the subtree, and like that are having. And the last, that is the K, L, M, N, O, you can see they don't have any children, so they are the leaf nodes. And we have various levels, that is the level 0, level 1, level 2, level 3, level 4. What is the level 0? This A, at this level it is only one node. At level 1, this is only two nodes. At level 2, 1, 2, 3, 4 are there. At level 3, only 3 nodes, and level 4, the remaining nodes are there. You can see it here. So this is we called as the height of the, this is called the height of the node. So two important things you can see here. One is a node represented by the circular, and other are the edges, they are represented by straight lines. You can see solid lines are there. It's clear? So these are just the representation of a tree data structures. Okay. So then we summarize like this. The tree data structure is similar to a tree we see in nature, but it is upside down. It also has a root and leaves. As you see, every tree has a root and it has leaves. And the root is the first node of the tree, and the leaves are the ones at the bottommost level. And the special characteristics of a tree is that there is only one path to go from any of the nodes to any other point. So suppose From this node I want to go this, there will be only one path. From this point to go this one, there will be this path. From this point to go to M, so this is only path exist. So this point to N, and like that, there is only one path exist. Okay. Then another data structure we come across, that is the graph data structure. So graph data structure, it is another important nonlinear. So tree and graph, as I told you, that these are nonlinear data structures. So graph is another case of nonlinear data structure. So it is similar to the tree data structures, but it has some difference. Okay, there is no particular root here. That is because previously in the tree data structures we are having a root. Here there is no. It is represented by nodes and it is represented by edges. The tree data structures with the difference that there is no particular root or leaf nodes, and it can be traversed in any order. But previously you have come to from the root, you have to go to the different. It is not like that. In any order you can go. A graph is a nonlinear data structure consisting of a finite set of vertices or the nodes, whatever you say, and a set of edges. So it is connecting a pair of nodes. So that means node 1 and 2 connected by this edge, right? So this is the concept of graph. Then we are having a number of algorithms. So the different algorithms we will go for that one, because now we have seen in general some definitions of the various data structures. Then we will go for some algorithm. We have the different algorithm, as I told you. One, the important is the searching algorithms. So this tree structure will study in details, that we are not covering here, because I am giving a general hints about the data structure. Each and every data structure will study in details. Okay, we will make one video for each and every data structures, whatever we discussed till now. Now in the searching algorithms, we have learned about some linear data structures, and it is time to learn about the basics of this algorithm, which are hugely used in these type of data structures. One such algorithm is a searching algorithm. The searching algorithms are used to find specific elements in an array. Okay, a particular element I want to find in an array or string or linked list or some other data structures. So this technique, finding something, we call it the searching. Okay, there are most common searching, there are three main searching techniques are there, or algorithms are there. One is the linear search, one is the binary search, one is the ternary search, right? What is linear search? So in this searching algorithm, we check for the element iteratively from one end to other end. This is linear. Okay, try to understand. In this searching algorithm, we check for the element, a particular element, iteratively from one end to the other. Okay. Then binary search, in this type of searching algorithm, we break the entire data structure into two equal parts and try to decide in which of these our element exists. So that means we make binary search tree, something is less than, something is greater than, we compare the number. If it is greater than, it will be to the right, if it is less than, it will be to the left, right? Then another is the ternary search. In this case, the array is divided into three parts and it is based on the values. One can be less than something, one can be greater than something, one can be in between. This is the ternary search. Okay, we decide the segment which we belong. Okay, you can see some example. I will show you afterwards. Then we are going for some sorting algorithm. The sorting algorithm here is one of the most used algorithm. Often we need to arrange or sort. Sort means we put it in order, ascending order or descending order. So this is called the sorting algorithm, right? So this sorting algorithm is one of that, is used for these cases. Based on the conditions, we can sort a set of homogeneous data in order, like sorting an array in increasing or decreasing order. Then sorting algorithm is used to rearrange a given array or list of elements according to a comparison operators on the elements. Okay, this comparison operator is used to decide the new order of the element. For example, you see the unsorted data are there here like this, 170, 45, all the things. Suppose you go for the increasing order, what is the lowest? Lowest is the 2, comes first, next is the 24, next is the 45, next is the 66, like that. So this is sorted in the increasing order. Or suppose you want to sort it in the decreasing order, then it will just reverse it. First will come 802, then it will come 170, 90, like that, like that. Okay, so we will study in details about these algorithms. Just we have in addition to this, we are having a lot of other algorithms like the bubble sort, the selection sort, the insertion sort, the quick sort, merge sort. On each and every sort with example, we will take one video and explain, right? Then we are having divide and conquer algorithms. So we are talking about the various algorithms. Now the divide and conquer algorithm, this is one interesting and important algorithm to be learned in our programming. Okay, As the name suggests, it breaks the problem into parts, then solve each part, and after then again merge. That is divide and conquer. First divide, then you sort it, then concatenate or merge it, like that. Okay, this is divide and conquer. So divide and conquer is an algorithm paradigm. So a typical divide and conquer algorithm solves a problem using following 3 steps. First is the divide, then you conquer, then you combine. What is divide? Break the given problem into sub problems of same type. Then conquer means recursively solve this problem or sub problem. Combine means approximately combine. So these are the 3 things we use in a divide and conquer algorithm, right? Then we have some other algorithm like the greedy algorithm. The greedy algorithm, it builds up the solution one piece at a time and chooses the next piece which gives the most obvious and immediate benefit, that is which is the most optimal choice at that moment. So the problem where choosing locally optimum also leads to a global solution or best fit or the greedy. Okay, the best fit, or we call it as the for the greedy. For example, consider a fractional knapsack problem. The local optimal strategy is to choose the item that has maximum value versus weight ratio. So this strategy also leads to a global optimal solutions because we are allowed to take, this is an example, you can see here A, B, C, like that. Here the fractional knapsack it is given here. So all things we can get it here. Okay, this example. Then is the recursion. This is also another data structure we are getting. So recursion is one of the most important algorithm which use the concept of code reusability and repeated use of the same piece of code, that is called recursion. The point which makes recursion one of the most used algorithm is that it forms the base for many other algorithms like the tree traversal, the graph traversal, divide and conquer algorithm, and backtracking algorithms. So all the things here we will be using some concept of recursion, right? Then we study something about the backtracking. Backtracking is an algorithm techniques for solving a problem recursively by trying to build a solution incrementally, one piece at a time. So removing those solutions that fail to satisfy the constraints of that problem at any point of time, then we can roll back. Okay. So some important and most common problem of backtracking algorithms are, this is the night stool problem, rat in a maze, n-queen problem, subset sum problem, m coloring problem, Hamiltonian cycle, Sudoku. All the things are the example of the backtracking algorithm. Then another important that the algorithm is the dynamic programming. See, another crucial algorithm is a dynamic programming. The dynamic programming is mainly an optimizations over plain recursions. Okay, this is the finding the best. It is not finding a solution, finding the best. Wherever we see recursive solutions that has repeated calls for the same input, but we can optimize by using the dynamic. See the example here in the recursion what you are doing. Some Fibonacci you are using it here, integer p, integer n. If n less than equal to 1, then return n, then return this one plus this one, all things you are using. But here while the same thing you are using the dynamic programming at a linear search. So you are using f of 0 is equal to 0, f of 1 is equal to 1. For I is equal to 2, I less than equal to n, I plus plus. So f of 1 which is equal to f of I minus 1, sorry, f of I which is equal to f of I minus 1 plus f of I minus 2, return fn. So at a time we are not calling it again and again. Okay. So this is the thing, the difference of this dynamic program. Another data structure we are having, that is the pattern searching. The main concept of the dynamic programming algorithm is to use the previously calculated result to avoid repeated calculations of the same subtask, which helps reducing the time complexity. That means what is the previously such things are there that can be, you can reused. We don't do it again and again. Then the important things what I am telling, that another algorithm, that pattern searching. The pattern searching algorithm are sometimes also referred to as the string searching algorithms and are considered as a part of the string algorithms, and these algorithms are useful in the case of searching a string within another string. Say for example, some text is there, this one, and pattern is there A, B, A. So here you have to see where it is there. You see A, B, A. It is already there here one time. Similarly, A, B, A, it is also there. You get it now. So this is the way of searching. This is the thing. Now we can have a brief review of whatever the things we studied. The classification of the data structure, it is done linear data structure and non-linear. Linear is divided into static and dynamic. Static is array, dynamic is queue and stack. Try to understand. So linear data structure is divided into static and the dynamic. Static is the array. Array means first we define array. Array size is equal 30. we cannot put the 30th element there, 31st. So it will be 0 to 29, so only 30 elements you can put it there like that. Dynamic means it can grow and shrink. So for example, linked list or the stack and queue, you can increase, you can decrease like that. Then the nonlinear data structures, we are having the tree and the graph, what we are discussing right now. So this is the general classification of the data structures. Fine. Then let us have the linear data structure. The data structure in which data elements are arranged sequentially or linearly. For example, we can say there are so many linear data structures like the array, the stack, the queue, linked list, etc. These are coming on the linear. You can see here in the linear, all the things that array is coming, queue is coming, stack is coming, because these are all linear. Try to understand. Static dynamic is different thing, but linear array, queue, stack and linked list, all the things are coming under that one, right? An example he has given. Then we go for the static. The static data structure has a fixed memory size, and it is easier to access this element in a static data structure. It is easier to access that element because it is size is defined and you can only limited things. So an example is the array. Dynamic data structure. In dynamic data structure, the size is not fixed. It can randomly updated during the runtime also, which may be considered efficient concerning the memory complexity of these things. Example is that I have taken the queue, stack, all the things are coming under this dynamic data structures. Fine. Then we come to the nonlinear data structures. I told you that nonlinear data structure, the example is graph and tree. So the data structures where data elements are not placed sequentially. Nonlinear means it will not be sequentially or linearly. So they are called the nonlinear data structures. So in a nonlinear data structures, we cannot traverse all the elements a single runway. No, there are n number of ways. This route, that route, like that, like that. Get it now? So this is the thing. Then we narrow our study on this different type of tree. One is the binary tree. What is a binary tree? Bi means two or rendu, whatever you say. By array, binary. So a binary tree is a tree data structure in which each node can have at most two children. At any cost, you cannot have more. It can have no children. It can have one children, or at best it can have two children. You cannot have three children at all. Okay. For example, one is the parent node. It has two children, that is 2 and 3. So 2 is a parent. It has two children, 4 and 5. 3 is a parent. It has two nodes, that is 6 and 7. You get it now? So now the topmost node is called the root. Here you see one is the root here. A binary tree can be visualized as a hierarchical structure with the root at the top and the leaves at the bottom. So 1 is the root, 4, 5, 6, 7 are the leaves. Okay. And the binary tree have many applications in computer science, including data storage, data retrieval, expression evaluations, network routing, and gaming, artificial intelligence. They can also be used for to implement various algorithms such as searching, sorting, and graph algorithms. Okay. The representation of binary tree, each node in the tree contains the following. Okay. Now the representation we can see it here. Just to define structure node, and this is the programming part. I think you can easily understand this thing. Then we go for the basic operations on the binary tree. We can go for inserting an element, you can go for removing an element, you can go for searching for the element, you can delete for the element. Okay. Then traversing an element, and there are four mainly. There are four, but mainly there are three type of traversals in a binary tree, which will be discussed at, right. So all the things we will discuss about what are the things. Now what are the application of this binary tree? If you see the applications, we use in compilers, we use in expression trees for this application of binary. These are the application. Then Huffman coding tree are also used in the data compression algorithm. Priority queue is another application of this binary tree that is used for searching maximum or minimum, that is the complexity is order of 1. Okay. So this is the best. Then representation of the hierarchical data. So these are used in editing software like Microsoft Excel and spreadsheet. This is used for indexing segmented at the database, that is used in storing cache in the system. Then syntax trees are also used for most famous compilers for programming like GCC, all the things are there. Okay. Then for implementing priority queue also you will be using. This is used to find the elements in less time, then used to enable fast memory allocations in the computers, and used to perform encoding and decoding operations. All these are the applications of the binary tree. Then let us go for the binary tree traversal. Okay. So tree traversal algorithms can be classified broadly into two categories. One is the depth first search or the DFS algorithm. Second one is the breadth first search or the BFS algorithm. So tree traversal using the depth first search algorithm can be further classified into three categories. One is the pre-order, one is the in-order, another is the post-order. Okay. So try to understand. One is the pre-order traversal, then is the in-order, then is the post-order. Okay. PIP, pre, in, post. Remember this. So the order will be current, left, right, CLR. Here LCR, left, current, right. Here left, right, current, right. Remember like this. Then what is the meaning of that one? We visit the current means we visit the current node before visiting any nodes inside the left or the right subtree. Here the traversal is root, left and right. Current means the root, left, right. Okay, it means that the root node is traversed first, then it is left child, and finally the right child. We'll study in details about this pre-order. So remember like this. Then in-order traversal, that is left current child, visit the current nodes after visiting all the nodes inside the left. So starting from the bottom left, then the parent, then the right, then the like that we will go on these things. Here the traversal is what is there? Left child, then a root, then the right child. This is the order. Then coming to the post order traversal or the left right current. So here visit the current node after visiting all the nodes on the left and right. You get it now? So we'll take an example there. We can understand all things, right? Now let us the tree traversal using the breadth first search first. Okay. So algorithm, it can be further classified into two. One is the label order traversal. What is that label order traversal? Let us see. Okay. So now breadth first, or we call it the label order traversal. So visit nodes level by level. That means in the first level it is only 1. So we visit 1. The second is here. The second level I visit 2, 3. After that we write here, see, level order 1, then it is 2. Last time you can see 1, 2, 3. Then is 4, 5, 6, 7. See, 4, 5, 6, 7. Okay, it is clear. Now, so this the fourth one, it is the breadth first I have given. Now we are going for the depth first. In the depth first I told you that we are having pre-order, in-order and post-order. So now let us see what I told the CL, the formula CL. C means setting the root. So root 1, then 2, okay, then so C left is 2. Again what is the left to this one? Again it is 4. Clear? 1, 2, 4. Then right, it is 5. Okay. Then what is that? Then it will come to left. So then 6. Then 3 and then 7. You get it now? So like that. First we go for the what I told, the pre-order. Pre-order it is 1, 2, 4, 5. Okay. Then it will come to the center 3, 6, 7. That is 1, 2, 4, 5, 3, 6, 7. Get it like this. Okay. So again I am repeating. So first is the center, then is the left, then is the right. So this is the center, first 1, then is the left is 2. Okay. Then you cannot move here directly. Then again you have to count the left. What is the left? Left is again 4. What is the right? It is 5. Okay. Then entire left is over. Then you are coming back to the left is 6. Then center is 3 and right is equal to 7. Okay. So this is the pre-order. Then coming the in order, this is the left, center, right. What is the left? First is the 4, the leftmost. 4, 2, 5. Then you go to the 1. Okay. The 1. Then 6, 3, 7. Okay. LCR. Then coming to the post order traversal, that is LRC, left, right and C. What is the left, right? So 4, 5 it is 2. 4, 5 it is 2. Then 6, 7 it is 3. Then finally the 1. You get it now? So these are the way we can go for the different traversal. Here is another example it is given. So I am going for the breadth first. In the breadth first, what is the first level? It is 1. Second level 2, 3. Next is 4, 5. That is 1, 2, 3, 4, 5. You got it now? So, or you can write 1 2 3 5 4 also you can write, no problem, or 1 2, it is all are there possible. Then coming the pre-order traversal CLR, you tell me what are the things to be done. First is the center, that is 1, okay, then 2, 1, then it is 2 CL, then it will come to the L, again it is 4, okay, then the right 5, then the right it is 3, is clear. Similarly, in order LCR, what is the leftmost? It is 4, center 2, then 5, then 1, then 3, something it is done. LRC, LRC means 4, 5, 2, 3, last is 1, okay. Then we will go for the different type of binary trees. The types of binary tree based on the number of children. So, following are the different type of binary trees based on their number of children. One is the full binary tree, second is the degenerate binary tree, third one is the skewed binary tree. Okay, remember these things. First one is the full binary tree, second one is the degenerate binary tree, third one the skewed. What is the things you see here? In the full binary tree you can see it here, see it has some note like that, but degenerated tree you can see here. So we have it is not no only sometimes left side or right side it is there, but this second third one is the left skewed. That means you see B node is less than A, C is less than B, D, so they are all coming to the left line like this, okay. Then coming to the right skewed, so B is greater than A, C is greater than B, D is, so this will be the right skewed binary tree, this is the left skewed, these are the fully binary tree and this is the degenerate tree, is clear. So these are the concept you remember, okay. Then also we can divide the or we can go for the type of binary trees on the basis of the completion level. So one is the complete binary tree, second one is the perfect binary tree, third one is the balanced binary tree. What is this thing? You see, one is the complete binary tree. In the complete binary tree, what you see? See, a binary tree is a complete binary tree if all the levels are completely filled except the last level. See, here level is completely filled, but the last one is not filled. Except that if all are filled completely, then we say complete binary tree. We say complete binary tree. Okay. Then we say the perfect binary tree. See, in the perfect binary tree, a binary tree is a perfect binary tree in which all the internal nodes have two children. Here the see these are the internals. This is internal. This is internal. This is internal. Internal nodes have two children and all the leaf nodes are the same level. Okay, internal are having two, here having two children, here having two children, here having two children. All the leaf nodes are filled. Okay, at the all leaf nodes are the same level. So this is called the perfect binary tree. Okay, so perfect binary tree is a type of binary tree. Okay, all the things are there. Then the third one we are going. Okay, these are things. Then we go for a balanced binary tree. Okay, the example of perfect binary tree is ancestor in a family, keep a person at a root, parents as children, parent as parents as their children, like that, it is the perfect binary tree. Then we are going for this balanced binary tree. A binary tree is balanced if the height of the tree is order of log n. Remember that. A binary tree is a balanced, or we call it a balanced binary tree. What is the condition? If the height is order of log n. Okay. So this is the things you have to follow. Where n is the number of nodes. For example, the AVL tree maintains order of log n height by making sure that the difference between the height of the left and the right subtree is only 1. That remember. Similarly, red black tree maintains order of log n height by making sure that the number of black nodes on every root is we will study in details. So number of black nodes will be same. We come to the left or the right. Acha. Then the balanced binary search tree are performance wise good as they provide order of log n time for search, insert and delete. Okay. We will study in details about this AVL tree as well as the red black tree that is there. And there are some special type of tree like the binary search tree, the AVL tree, the red black tree, the B tree, B plus tree and segment tree, right. So you see binary search tree, you see here I have the root node is 8, left hand side 3 is less than this one, and again to left it is 1 less than that one, and 6 is greater than 3 but less than 8, you see. Then here 10 is greater than 8 and 14 is, this is a binary search tree. In the AVL tree, what I told you that the difference between the height. Here you see, here height is equal to what is this? It is 1, 2, 3. Left side is 3. Okay. Right side it is 1, 2. 3 minus 2 it is 1. Here it is 1, 2. 3 minus 2 it is equal to 1. So difference of height is equal to 1. Then it is called a avial tree. Then red black tree. Okay. You can see the root node will be black, and the number of black you go for any roots. Here also 2, and here coming also it is 2, because this is I am considering black and the red is red. And see, up to this also, here also black is 2. This is 1 black, this is 1 black, this is 2. Then coming to this one also, this is 1, this one is 2. So this is called the red black tree, right? So these are the some special cases. Then we will study in details about the binary search tree. The binary search tree, it is a node based binary tree data structure that has the following properties. The left subtrees of a node contains only nodes with key lesser than the node's key. Okay, the root key. Okay, that you see inside the circle what you have written, that is the key. 8 is the key, 3 is the key, 1 is the key. So all the key in the left subtree, they must be smaller than 8, and all the keys in the right subtree, they must be greater than 8. So you see 3 is less than 8, and coming to 3, 1 is less than 1, 1 is less than 3, and 6 is greater than 3. In the same time, all are less than 8. Here right side all are greater than 8. Okay, so 10 obviously greater than 8. So then something is less than 10, so it should not be less than 8. It cannot be 8 also, because 8 is already there. So it can be less than 10, it is 9 is there, and greater than 10 it is 14. Even if 9, 14, they are also greater than 8. So this is the binary search tree. Okay, you get it now. Then we can go for the avial tree. Avial tree, I told you that the difference of height should be 1. This is an example of the avial tree. You can check it here. But anyway, we will be studying the same thing also I told about the red black tree. Here the condition I told that the starting node will be black, and the number of black we explore in any path, it will be same. You get it now. And any new node you are creating, it should be red, and there cannot be any two consecutive red and red. So these are some conditions we will be following. So it was invented in 1972 by Rudolf Baer. Okay, these are the things you remember, and we will study in details. Then we will study the concept of B tree and also B plus tree in our next video. So till then, you please take care of your health, and have a good day. You like this video, please do share with your friends, and also don't forget to subscribe, because your subscribe gives a lot of inspiration for creating new videos. That is one point. Second point is that without any delay, all the videos can reach to you. Thank you once again for watching this video. Bye.